Hi, in this video we're going to talk more about half-life. Now we learned a while ago what half-life is. It is the amount of time it takes for 1/2 of a sample to decay. Decay is a continuous process but noted by half-life. Rate constant is also dependent on temperature, so as temperature changes, so does half-life. Now what is the half-life we're going to learn this time? We're going to learn that T of 1/2, aka half-life, is equal to 0.693 divided by K, whereas K is a rate constant for any reaction. So for example, if it tells you that the rate constant is a certain number, all you have to do is divide that from 0.693, and then that will be your half-life. So let's say the rate constant is 3.4 times 10 to the negative 2. So you'll do 0.693 divided by 3.4 e to the negative second, and then you'll get 20. So half-life for this substance is 20 with a unit of time, either minutes, seconds, or hours, but you know it's 20. Then let's say you're given the half-life. Let's say the half-life for a substance is 15 hours. All right, in this case you're going to use this formula. Concentration of A at a time is equal to the concentration of A initial times 1/2 to the tth power. So let's say, what is the concentration? Let's look for this, right? What is this concentration after 45 hours have passed? Now 45 hours, you first need to divide by the original half-life, which will give you three half-lives. Now you plug this 3 into time. So you'll get, let's say A initial is 100 to make it easier, 100. So after 3 half-lives, you'll do 100 times 1/2 to the tth power, which in this case will be 3. And then you get 12.5 as the new concentration after 3 half-lives has passed. Now, what if you're looking for this? Let's tell you that it's going to be 12.5 after a certain amount of time period, which you do not know yet. Is equal to 100 times 1/2 T. Now, what would T be to result a concentration in this? Well, in this case, you just need to divide 12.5 by 100, which gives you 0.125 equals 0.5 to the tth power. Now you can do the log of 0.5 and 0.125, which is 3. And this will be 3 half-lives. 3 half-lives. Now, depending on how long the half-life is, you need to multiply it. So we said one half-life is 15 hours. So we're going to have to multiply this 3 by 15 to get the total amount of hours, which will be 45. Okay, so we have a practice question here, and let's see what we're given. First, we write the formula down. Concentration of A at a certain time is equal to the initial concentration times 1/2 to the number of half-lives. And I said you're given with a half-life for 20 minutes. If you're not given the half-life, then you're going to have to use this formula. You're going to have to use this formula to solve for the half-life. 0.693 divided by rate constant. Now we're given with half-life formula, and it tells you how much remains after 80 minutes. So we're looking at how many moles remain after 80 minutes. We're looking for this. Okay, so now let's start putting numbers in. Equals initial, we have this much sample, which will be 3.2 times 10 to the second power, times 1/2. How many half-lives are there? T is not the total amount of time. T is how much half-lives are there. So let's see how much half-lives are. 80 minutes, and each one is 20 minutes. So we will do 80 divided by 20, which gives us 4. So there will be 4 half-lives, and our exponent will be 4. Now that gives us our mole number after the 4 half-lives. So we'll do 3.2 e to the second power times 1/2 raised to the 4th power. Now that gives us 20. So after 4 half-lives, aka 80 minutes, we will have 20 moles of the original sample. Thank you for watching.